Yeah.
Uh.
No. Hello, everybody, and welcome to the 126th Melbourne AWS User Group Meetup. We've got a wonderfully big crowd here, actually, in person. So if you're watching online, well, you're not completely missing out, but you don't get to be with all these fun people. Before we get started, just as always, in the spirit of reconciliation, the Melbourne AWS User Group acknowledges the traditional custodians of country throughout Australia and their connections to land, sea and community. Our in-person meetup is being held on the lands of the Wurundjeri people, and I wish to acknowledge them as traditional owners of this land. We pay our respect to their elders past and present and extend that respect to all Aboriginal and Torres Strait Islander people today. I also want to remind everybody that we have a code of conduct. A short version is here on the slides. A more extensive one is on the link, but it basically comes down to be a good person. So if you have any, if you feel like somebody is not behaving according to the code of conduct, reach out to one of the organizers, or myself, Rob, Matt, or Dawn, or Jason, and we will take it from there. Additionally, you can also file things anonymously through the website. We're on the website. We're on the internet for stuff. Our website, LinkedIn, Mastodon, YouTube. If you're watching this on the live stream, you probably found that one. And technically speaking, Twitter, as long as it's alive. Not yet on Blue Sky. The plan for today: introductions, which I'm doing now. After this, Dawn and Jason will be taking over to tell us all about what's new. I can give you a sneak peek. There was a lot of stuff in Melbourne this month. Then this is followed by our two main talks. First up will be Praveen, who will talk about GitHub runners on EKS, which is definitely interesting. And afterwards, Gokul will be talking about implementing workspaces. Again, possibly a very interesting topic. We'll end the day. We'll end the night then with Marketplace, basically who's hiring section. Here you can hold up your hand if you're looking for people. We do it this way around because it might be awkward if you're going to say, hey, I'm looking for a job, and your current manager is sitting next to you. You know, that's not the best thing. So you might just say, yes, you are. And then we'll finish up for the night. So with that, I'll hand it over for the news section and get out of everybody's way. Oh, actually, not quite done yet. Sorry. I forgot what I have in my slides. Terrible. You can always ask questions. For the online audience, you can ask them in the Slack or in the YouTube chat. That will all work. We'll then read the questions on your behalf. Also, of course, once again, want to thank our sponsors, our gold sponsor, CMD Solution, as well as our silver sponsors, Versant and Civo. Fun fact, two of these sponsors have given talks today. So they are, at this moment, my favorite sponsors. Is there anybody here from Versant? Good. And of course, I want to thank NAP for this beautiful venue where we can see screens in multiple places. It's still a great place to be. I've mentioned the Slack before. We're almost at 1,000 people in there. So there's usually conversations going on. Outages has been very quiet lately. Either we don't notice them or There just haven't been as many, but there's a lot of conversations going on about things. So join and chat to people. Also, always looking for people to help out. Mostly speakers. That's what we need the most. We're covered for sponsorship for this year, as well as volunteering. If you want to help out with anything, just reach out to one of us and we'll see what we can do. Upcoming events. Reinforce will be in 2 weeks. If you don't have a ticket yet, you're probably too late. But it's coming. reInvent is coming. Tickets will go on sale on the 14th of June, from what I've heard. It's probably US time, so it might be the 15th actually. If you go, is anybody planning to go to reInvent?
Maybe.
See a couple maybes. Well, it's always fun to go if you are going. Closer to home, next week there's the data engineering meetup. They don't have speakers announced yet, but considering it's at the AWS office, I fully expect that it will be covering AWS things. It would be kind of weird if they'd start talking about Azure. The week after, the AWS Programming and Tools meetup has a very topical topic with building generative AI applications with SageMaker foundational models. Sounds like how to build your own ChatGPT for free. Well, not for free, for less.
Or more, depending on how much the AWS credits cost you.
Or more, yeah. And 2 weeks after that, the serverless meetup is also back. This one has not been announced yet, but I know that we're hosting it at my office, and the one speaker that is aware is one of my colleagues. So I'm already mentioning it. Keep your eyes open for that one, because it should be good. And then finally, I can actually hand it over. Thank you.
Actually, bonus points. If anyone is going to reinforce, Forward CloudSec is the day before, and I will be speaking there. So if you want to come and hear an extended version of my rant on CDK from a little while ago, there's multiple security-specific conferences running in the same place.
Alrighty, so what's new? As we start off with, now we have finally in Melbourne. So as Ian had hinted, there is a lot that's come to Melbourne. So
Finally in Melbourne, a semi-functioning AWS region. I mean, if you want to run generative AI, you've got SageMaker. The question that interests me there is, given how large given that SageMaker could almost be a suite of AWS services on its own, how much of it has made it in?
yeah, and that was sort of asked of me when we were talking in the lead up. Was, you know, hey, there's a lot coming. Is it right to go? And the advice I gave was just check, because even though your services may be listed, it may not be all there. So, you know,
Yeah.
test it out. It's looking a whole lot better for the tools. I mean, you know, this screen here, Security Hub,
CloudFormation, yeah,
FSX.
Firewall Manager, CloudFormation stack sets. If you're doing anything with orgs, you basically have to have that to run. If you're running a multi-account strategy, you have to have CloudFormation stack sets to run. So that sort of top half of that slide, it's like, yes, this is looking like it's slightly more functional now.
All right, and the next slide is usually finally in Sydney,
But SNS works as expected now.
yeah. So again, lots of cool stuff. AWS backup support for cross-region backups.
Zonal shift for Route 53 ARC. So if you're using that for the purposes of disaster recovery, you can now shift across availability zones in Melbourne as well as Sydney.
Yep. EFS replication. So yeah, lots of stuff now in Melbourne that definitely well worth having a look and seeing if it'll work for you.
Yes, my advice would be you won't know until you try it. So if you already have templates and things which you're deploying in another region, I'm guessing probably Sydney, give it a go and see how badly it breaks.
Hey, and now finally in Sydney. So a couple of new instance types and the Gravitron 2. So that's good. Yeah.
I mean, you might be able to actually get some of those instance types in Sydney, unlike some of the other ones where they're starting to get throttled.
Sorry.
Yeah.
All right. And databases. So, yeah, I mean, most of these ones are fairly self-explanatory, but, the one that I was not aware of and had a look at, the Aurora I/O optimized. So now you've got two different options for Aurora, standard and I/O optimized. So if you're not doing a lot of I/O, it says that standard will be your cheapest option. If you do heavy I/O, then look at I/O optimized. For that one, you just pay for the instance type and the storage. You don't pay based on I/O.
And I remember being up here, what was it? I think it was late last year, so probably 7 or 8 months ago, talking about the read replicas, the RDS read replicas. Well, now you've got them for the multi-availability zone read replicas. Well, now you've got them for Postgres as well.
Yep. Quite a bit on the machine learning side. I mean, that seemed to be a hot topic for AWS recently. So yeah, I mean, the interesting one that sort of stood out for me too was the recognition launching the face occlusion detection. So it sounded interesting. And then, yeah, your Code Guru and Code Whisperer plugins, extensions available.
And I'm actually going to pull basically the one that you didn't. Amazon Translate launches real-time document translation. Now, as someone who has, on occasion, been able to translate between more than one language, more in the idiomatic sense, because I've kind of let it fall into disuse, but with much, much better accuracy than most translation engines, which don't actually understand idiomatic language. I'm really curious to see how good that is. See also if anyone has ever bought electronics parts from China, where they've clearly just run the instructions through Google Translate. I am really, really curious to see whether Amazon can do this any better than most of the providers out there. Particularly because that real-time document translation, the other interesting thing with it is if you go and dig into the subset of languages that Amazon Translate supports, because it is nowhere near what you get out of things like Google Translate. But generally, if you work on a smaller subset of languages, you're going to have much higher accuracy. So this is one I might actually go play around with.
Networking, so yeah, the firewall ingress TLS inspection, so that will be interesting. I'm not sure how I feel about that because one of our customers has done a similar thing, and it's been a pain in the backside trying to deal with that. But hey, that's there. So private access to the management console. I was having a read up on that, and I'm not sure there's probably use cases.
That has to have been a feature request from someone.
Yeah.
There are those announcements which you can look at and you can just go, this was a feature request from some really big customer. Private access to the management console absolutely was one of those.
Yep. So, DevOps, AWS backup support restoring resources with tags. So
yes.
That's, yeah.
Finally.
So yes, if you've got your tags, it'll have the tags on the backups, and so you
And
can
on
just
the restored resources,
so you
which
can
was
just pull that back.
yeah, that was one of the things which for the longest time made backup basically unusable if you had any significant number, if you had any significant set of deployments to AWS. Well, and if you had those and you weren't managing them with tags, you probably weren't having a good time. But if you had those and you were managing them with tags and you had to restore them, that was always fun. And I know that was that was something which turned multiple people that I know off using backup.
Yeah. And the other one, backup now supports AWS user notifications. So not so much on the backup, but the user notifications is interesting. I've had a little bit of a play. It's sort of a new feature to get notifications from various services.
Look,
Yeah.
it could be worse. And it's sort of, I mean, I can kind of see the rationale behind it if you're really trying to push AWS backup as like your central place for doing this. But it's, as with so many of these services, it takes a lot of time to get it to that point. So you can kind of look at it and go, well, this is clearly what they're doing, but it's not there yet.
Other cool stuff.
Security Lake is general availability.
Yeah.
I cannot wait to see how much money people spend running Security Lake in production, and I cannot wait to hear from people whether it is worth the amount of money that they spend. If you're not familiar with this, what Security Lake basically is it's a data lake, but for security information and notifications. So that can be it supports logging from certain sources. It supports alerting from certain sources. The aim is basically you can have all of this data in one place. You can query it all. The thing is that data lakes are hideously expensive, as any of the data scientists in the audience will probably tell you. Security Lake promises to be no different. I really want to see if this ends up being worth the money.
Yeah. So one of the interesting ones popping out, the introducing Cedar. So yeah, an open source language for access control. So, something different to add on top of your IAM policies. So one thing that may be interesting to look at for those that know this guy up in Sydney, Ian McKay.
Yes.
He's got a whole heap of like cool tools to do stuff with AWS, and he's just
Released one for Cedar.
Released one for
Yeah.
Cedar. So
Ian McKay, AWS community hero, all-around great guy, is also single-handedly responsible for the source of truth on AWS IAM permissions and what they actually do. So Ian releasing tools which run with Cedar, not only is it a natural progression of things that he's already done, he's absolutely the correct person to be doing this. So if you want to check out Cedar, go look at it. Go look at the things that Ian has done with it. I kind of want to poke that one too at some point.
Yep. And then the rest of them are all sort of fairly. And there's a couple of Amazon Connect ones there.
Hi,
for
Matt. Well, I feel obligated to spare a thought for Amazon Inspector, given that was the first talk that I ever gave here, and it's now actually a functioning service which does what it says on the tin. Which, when I gave a talk on it, 2020, so that was probably about 3 years ago now, it was not. If you ever find yourself needing to resolve vulnerabilities, Amazon Inspector is now a reasonable way to do it. And you can go search the database that it uses, which is really useful if you have vulnerabilities popping up and you want to get more information on what is actually going on with them.
Yep. And although this is Melbourne AWS user groups, if you're doing anything with people in Auckland, local available. So Yay for an NZ cousins.
Yes. I believe this is going to be this is the precursor to at some point there are rumblings of a full-fledged AWS region somewhere in somewhere
Auckland.
in which is going to be Auckland. Yeah. I don't keep that much track of the region rumors until it is officially on the list of regions which AWS is in the middle of building out.
Well,
Yeah. But they always get delayed, IN.
which is Melbourne.
Okay, they always get delayed by our metrics.
Yep. So that's it for what's
Yes,
new.
that is it for what's new, and we will now hand back over to
Ian.
Ian to introduce our first speaker.
Thank you, Dawn and Jason. And yes, indeed, that brings us to our very first speaker, which is Praveen. Praveen has 13 years of consulting experience, predominantly in DevOps, cloud, and now containers. He's also a lead consultant at our gold sponsor CMD, which makes him one of my colleagues, which is definitely not the reason I like him. Not the only reason. So with that, if I will hand it over to Praveen and
All good? Yep. Thanks, everyone. Welcome everyone for today's session, and thank you for coming in. Today, I'm going to talk about one of the client implementation we have done for GitHub Action Runners and with EKS. So, because of time limitation, I'll quickly go through my introduction. Mostly, Ian covered. That's the only thing I will add on is AWS SME. And what is that? Basically, I'm part of AWS SME program wherein I am contributing to AWS exam. So I'm writing questions that goes through certain review cycle and comes to your exam. So if you're appearing in exam, you might find a question which is basically written by me. So yeah, that's the only thing I have to add on. Rest, thanks Ian for covering my introduction. So yeah, I'll quickly go to the today's topic. So what we are going to cover today is GitHub Actions. As you know, GitHub. So what in general GitHub Actions are? GitHub comes up with a native integration to automate your workflow. So whatever code you have in GitHub, you can have a native integration. A workflow will basically run behind the scene. You can see in the same window. And you will see all the steps, processes, approval, and complete workflow automation is supported in GitHub itself. Same is in GitLab as well, you will see. It also works on events. Basically, your pull, push, request, all these events is covered in that automation. So every code these days in GitHub basically need to have certain type of automation. Even if you have plain code, it required to be uploaded in artifacts repository, building the code, sanity check, or if you have any infrastructure as a code, so it need to be deployed. So every code need an automation and workflow to support it. Now with this GitHub Actions workflow, basically it's supported in all sort of operating system, be it Windows, Mac OS or Linux, or even my laptop as well. I can configure, GitHub Actions runner application, and I can run those GitHub Action in my laptop as well. And specifically on Mac OS right now, because AWS also provide Mac OS operating system, people are now running iOS application built in EC2 server. So what you have is basically you have a Mac running in EC2 server, which is basically integrated with GitHub, and it gives you a facility to build your iOS application in automated fashion. And we did that implementation as well with one of the client. It supports a lot of programming language, yes, because it runs within container. So you have your open source container, or you can have your own custom container if your application is really customized. And yes, it has a lot of open source plugins. So there are like marketplace having many open source plugins that supports your automation. So that's introduction of what GitHub Actions in nutshell. Now let's talk about runners. So obviously, if there is workflow, it required certain VM, certain machine to run. And that's why we have facilities from GitHub, like, okay, you have two kind of runners at the moment. One is GitHub hosted runners, wherein you specify environment in terms of Docker images. For example, if you want to run your workflow in Ubuntu or Windows, you just provide those image specification. It will run by GitHub. What does that mean is all the VM, scalability, and the security, everything is handled by GitHub. Whereas in other setup, which is self-hosted, you basically bring up your VM registered with GitHub, and it actually hosts your workflow running. And of course, if you are running yourself, you are maintaining the scalability, security, and all this sort of things. So it's all your responsibility. Okay. Now let's talk more on self-hosted runner. So let's go next slide, which is like how many kind of self-hosted runner implementation right now happening in right now. So people are using simple EC2 servers VMs as a runner, which is like having simple auto scaling group, EC2 servers with IAM security, your encryption, everything is inbuilt. That's plain structure, wherein you have upfront EC2 servers running all the time. You have to maintain your off-peak usage and scalability, everything. There is another implementation which is in the market available at the moment, which is using serverless framework, using Lambda, SQS, and all the event triggering. And it basically launches a Spot instance for you. The only drawback, or I can say it's less with this second approach, is Spot instance takes time to spin up, like 2-3 minutes. So assume that your one Spot instance running 10 workflow automations. Every 10th automation required a 3-minute delay. So if you're having a huge work actions running on daily basis, like if you have 1,000, you are getting delays of 300 minutes added on it. So final one, which we are going to talk today, is EKS one. So we are not comparing any of these sort of implementation. I'm just explaining you the third implementation which we did for our client. And it's more of a EKS sort of implementation where we are running everything in EKS. Yep. Okay, so let's talk this architecture in a brief. What we added in this particular architecture is a carpenter. Sorry. It's not us, it's not me. Okay, so a carpenter is interesting thing we have added. So you can see if you go to marketplace, say GitHub Actions in EKS, you will see one implementation. If you already have EKS, even if you don't have, you will see one implementation. What we did differently here is we use an open source utility, which is like Carpenter. And how we did it, that particular architecture, I'll spend some time on it. So what goes at the down here is basically we have AWS, we have EKS cluster, the blue square. Normally EKS, we having a managed node group. That node group we are managing only for controller application. So what is controller application? Is the main application that required to be run all the time. It can be your monitoring or your DNS or kube proxy, these kind of applications. So we have that controller application. On top of it, we then have action controller, which is integrated with GitHub using personal access token. And there's another application called Carpenter. And that deployed on your core cluster as application. Now what Carpenter is doing here is basically, so Carpenter is dynamically adding, managing your nodes, which is going to be added, updated dynamically. So in a sense, if you have managed node group, you will again have nodes, but it's like upfront. You have to basically define those node groups, scaling everything. But if you have Carpenter, it basically listens to your workload. So if you don't have any workload, it basically has 0 nodes in the cluster. And the moment you say, I need certain type of nodes, which is defined in Carpenter upfront, Carpenter will launch the node in instance. So that saves a lot of cost, and it basically gives really granular way of scaling the node group, which is basically hosting the GitHub runners. On the other hand, we have action controller that basically listen to GitHub for any actions requested, and it just launched the pods. So think of this scenario where there is no workflows running, there is no runner pod in the scene, Carpenter will have no nodes. But the moment action runner says, oh, there is a request from GitHub to run an action workflow, it basically requests a runner pod, and Carpenter will launch a node and the runner pod. And the runner pod will then registered in GitHub on a particular runner group. Runner group is basically organization of runners in a certain categories that you can then control in GitHub in access control. So your all repository need not to have all runner groups and so on. So like prod runner group, non-prod runner group, and so on. Any question on this slide? I will move. Yep. Do we have? Yep. Hello. Hello.
My question is on, question is on Carpenter. Is the Carpenter controlled by its own controller, which is serving the runners
Yes.
only, or for the other parts of the application? Is it?
Yeah, for this particular implementation of the context of this presentation, we are using only runner, but Carpenter in general works for other workload as well.
Okay, so how are we?
So it's like configuration files. You
Yeah,
have
yeah.
like one configuration. It's like auto scaling specification,
Yeah.
but auto scaling only triggers when there is a workload request.
Yeah.
So you basically do taint, toleration,
Yeah,
and those
yeah.
kind of configuration.
Yeah.
And in the Carpenter, will basically have a configuration says I have 3 kind of node in specification. If there is workload coming for any kind of node specification, it will launch a node.
Okay, so the
It
Carpenter over here is also providing pods for other workloads,
Yes.
not only for runners. That's
Yes,
what I want
yes,
to know.
yes,
Okay.
yes. But for the context of this presentation, we are just concentrating on EKS dedicated for GitHub Actions.
Got it. Got it.
Thank you. Yeah. What's inside EKS? So let's now go down to next level, which is like so inside EKS we have simple managed node group. We have then 2 controller applications, Action Runner Controller and Carpenter, all deployed using Helm. And then the Carpenter node groups are basically managed by Carpenter, and the runner pods managed by Action Runner Controller. So we just need to manage, we just need to launch a managed node group, Action Runner Controller, Carpenter, and that's it. After that, we just need to have any specification. All the rest of the things are basically managed by these 2 controllers. That's like automation start, like how we basically automated and deploy this text. Now that's another interesting slide to share, the scaling part, like how we basically scale. So with managed node group, it's completely like a simple auto scaling group where you have a CPU, memory, those kind of factors to scale. In our case, we manage all the controller application in managed node group. That gives us a guarantee that it will not, basically because controller are very limited pods, so they don't go really high usage or anything. So they always keeps in a certain certain limits. So managed node group, we always have, we haven't seen any scaling in managed node groups, like 2 or 3 nodes enough for our core cluster applications. Then we have Carpenter. Now Carpenter basically have only the configuration and says, okay, I have XYZ node types configuration with me. If there is workload coming in, I will launch it. And then it has next level of granularity, like your request resource and everything. So that managing all the auto scaling of your node groups using Carpenter. It goes to 0 as well. So you assume that there is no workflow coming in. It basically goes, make it 0. Because the controller is always running application. It always listen. So always listen the workload. If there is no workload, do node group. You save a lot of cost on that. Then with Action Runner Controller, which is the GitHub Action Runner Controller, that comes with another scaling application, which is like horizontal runner autoscaler. That is another like configuration definition. And that gives you very granular metrics to define for scaling your pods. Like how many workflow events you are running, how much your runner pods are busy. Like there are a lot of granular metrics available that you can configure to scale your runner pods. And again, like there are certain cases where there are a lot of build runners are going on, there's less deployment runners going on. So all this scalability you can define in action runner controller. And again, all these runner pods are different in the sense configuration. Like you can have something like Maven runner, Terraform runners, and so on. So every different kind of runners, you can have different kind of compute using Carpenter. So I assume that you have a really high CPU usage Java application. So you will basically have a Carpenter node group dedicated for that Java application runners, and you will manage that complete stack separately. So there are different permutation combination, but yes, there are like 3 level of scaling configuration you will get. One is normal AWS node group, but yeah, there are 2 different scaling configuration you will get is basically Carpenter and your horizontal runner autoscaler. Just checking time. And next is security. So if you run your runner in EC2 or a spot instance, the 2 other approaches apart from EKS, your security basically comes with your EC2 server. So if you have IAM instance profile, if you are running EC2 server within IAM with IAM role, all the security is added by IAM role. So assume a situation where you have a application builds and application deployment. Your application builds not necessarily require all the IAM permission, but it basically exposing anyways, because if you are running it within EC2 server that has different access limitation as well, you basically launch. You basically doing lot many other basically exposed to do lot many other things using your workflow basically. So what essentially this particular setup provides us is to have IAM role at every level. So manage node group, yes. Then you have action controller using IAM role. Carpenter node groups again having IAM role. So up to here it is same, like Carpenter nodes having IAM role, it's the same setup as you have normal EC2. But then we have next layer which is like pod level. So we can have every pod running with its own IAM role. So you can think of scenario where you have build application where you just zip your code, upload to S3 bucket. Your pod will have a service account, IAM role that has only access to S3 bucket upload, and that's it. So you can have that granular access to your jobs that it only require with having only required access. So you don't need to you basically save your lot of security concern on running a GitHub runner in a EC2 server which has lot more security exposure than required. Good. Next. Now there's a organization of GitHub runners. So now we got runners, we got GitHub Actions integrated with EKS. Now we have runners on demand from GitHub. How you basically organize? So you have different runners like build runners, dev runners, prod runners, and so on. And they basically registered back to GitHub in a runner group. So what we did basically, we have build runners that only have exposure to certain repos like build repos. We have then dev deploy, then we have prod deploy. And you can see there is one mono repo as well. So mono repo actually having both type of runners associated with it. So what we are doing is we have repositories, and inside repository there is configuration called, in the runner group, you have configuration to say how many repositories you want to add this runner group. And that's how you limit your repositories to expose to the runner. So that is additional level of security I can say, because then in that case your build runner won't have any sort of mechanisms to go to dev deploy or prod deploy runners. Okay, so that's a simple organization. So the moment it get registered, it registered with a runner group, and that runner group is limited to certain repos. Okay, how we basically implemented a runtime workflow. So that is actually I'm giving a simple example of deployment in a AWS, which is basically deploying EC2 servers. So starting from 1, so GitHub says, yes, I need a deployment of EC2 servers triggered. So EKS launch a runner pod with the pod role. The pod role will basically have ability to assume role in the target account. It basically assume a role and that again, the additional step to assume role, that means it gives you another level of security, that if you are just running, say, Terraform deploy, it will not deploy blindly to any account. It basically says deployment role, assume it, and then you trigger a deployment. So that's a simple workflow of deployment of ISE using EKS, runner pods. Cost. So very quick slide on cost. EKS, of course, there is additional cost of EKS. If you are just running plain EC2 server versus the EKS implementation, you will have a cost on EKS. You can save the AWS node group using Fargate as well. That's one way to save the cost. Carpenter again, when launching nodes, basically it will add your cost. But again, that's the same cost as having a EC2 server or a spot instance independently as well. So after EKS, all the cost is basically same in other implementation as well. So you're just having addition of AWS EKS on top of what you are implementing right now. What things to be considered? So in terms of GitHub organization, we considered runner groups. So as in previous slide, I showed the diagram by prod runner, build runner, dev runners. Every workflow has runner group tag. So every runner group has a tags. So those tags are actually defined in our workflow. That's actually fixed, like, okay, workflow will go to a particular tag to choose a correct runner group. So if you copy, assume that there is some dev repository, you copied complete workflow to prod repository, but you haven't updated any tags, nothing will happen because there is no dev runner associated with the prod repository, or vice versa. If you copied a workflow from prod to dev accidentally, still you don't get that because the tags are basically using prod and you don't have prod runner in your dev repository, so on. Limiting runner groups with repos. So there is a way to say every runner group is exposed to all repos or limited repository. So in a GitHub organization, I can say. So in our case, we limited the repositories. It means we don't have like any runner group coming in and it registered to every repository in the organization. We have then IAM roles for runner. So every pod has an IAM role, which means like it has added layer of security that it won't go and expose and do any accidental deployment. From AWS and Kubernetes side, we have Carpenter provisioner. So we added Carpenter as an additional layer of management of node groups. So that provisioner is basically having definitions across it. So there is no node, but definitions are there. It just listens, and the moment there is a workflow request coming in, Carpenter will basically launch the node. IAM roles and service account, everywhere we considered. We considered spot instance a lot and dedicated instance for managed node groups. And there is another event happen when you use spot instance a lot is an interruption event. So when the spot instance is going away, AWS sends you notifications. So we are using SQS for that interruption, and that is also built in Carpenter. So when you're using Carpenter, it basically comes with that additional facility. So you can have SQS, and Carpenter will listen to SQS, assume that there is an interruption event happen. It basically drain all the pods to from the node, and it will allow the node to go away. How we did that? In my client, we got like 1,400 repositories actively running daily basis. We got many type of workload like production, non-prod, builds, multiple platform and build as well, a lot of languages. And again, we got another type of implementation here. Yes, it is EKS, but there is like dedicated and co-located. So dedicated means we have like GitOps EKS, wherein you have only runners all across the EKS. But we have co-located as well. So co-located means they have actual application running in EKS, and then we have GitHub runner controller as well installed alongside with it. So that means you are doing all the EKS thing within the EKS itself. So you are not going, having any other integration outside of EKS. That is running some batch jobs and in GitHub runners and some data modeling jobs or something. We are running within the EKS. We got like really 1,000 jobs running on daily basis, and it is like off time. So our client is completely working, like all the development team are like on site. So that gives us like every, like peak usage on daytime, off peak usage, everything goes down to 0. And that's how. So that basically very dynamic. So we basically save a lot of cost in there as well. We use a lot of spot instances with interruption handles. All good. So that's all from me today. Any questions so far? Yep.
One moment.
Yep. So my question is about the. In fact, I have two questions, and the first one is about the auto scaling layers, the 3 layers which you just explained there.
Yep.
So if the controller pods are running in a managed node group, what benefit does Carpenter provide over the good old auto scaling group, which can scale down to 0? Because the cluster autoscaler is going to increase the capacity as and when there is a pod being scheduled.
Yeah, it basically when we try to go down to 0 level, wherein because we have really uncertain workloads coming in, so we can't basically afford to have like pods ready for every workload. So Carpenter is basically like definition based, like you have a definition of all the node groups, and it will only launch when there is a request for a pod. So if you know the toleration and tenting, so you basically have a pod definition that says tent GitHub runners. Okay, so now it basically wait for label GitHub runners from the pod. So if any pod says, okay, I want to run a node selector GitHub runner, then only it will launch. Otherwise it will not launch. And that's how. So we basically removed the autoscaler completely when we started with Carpenter, because we removed the autoscaler because we thought it's unnecessary after that.
Okay. And the other question is about the horizontal runner autoscaler. I mean, I might have messed up the name there, but there was another scaling component for the runners.
Oh, the GitHub runner actually.
Yes.
So that basically it just limited to pods only, like how pods are basically created with the GitHub workflow events. So it says how many workflow it's triggered or how many pods are busy. So that event's basically analyzed in controller and it will launch the pods accordingly, like deployment replicas, you can say. So your deployment replicas is basically governed by GitHub action runners based on the metrics coming in from GitHub, not like CPU or any resources, like based. So if you have like many jobs are going on to serve that workload, GitHub action runner will launch the sufficient pods to serve your workload.
Okay, so that's a independent component.
Yeah, it's an independent component from normal scaling. Yeah,
thank you.
But that gives you granularity to go to GitHub, action and workflow counts basically. Yeah.
All right, thanks. I've got a few, but I'll try to stick to one. We use Azure DevOps, which is like reasonably similar, right? Both Microsoft. They also have an option for self-hosted containers, but when you sort of spin them up, we had a crack at it using Fargate. You tend to have to pick one pool or another. So we wanted to make use of sort of both the Microsoft hosted agents because they're readily available, as well as our self-hosted. Are you able to sort of pick and choose or use whatever's available at the time? So if you've got something that needs to be run immediately, and you don't have a pod available, can it quickly be run on like a GitHub hosted agent, or do you even make use of those at all?
So we got mixed implementation as well at one place, wherein we use self-hosted runner plus this one, but that is for usability purpose, like build jobs can be run on independent GitHub hosted runners, because for build we don't have any integration, but for deployment we have integration with AWS accounts and everything. So we basically can't run those jobs with GitHub hosted runner. So we have to rely on self-hosted runner for that.
Okay. Yeah. And are there any sort of special requirements on the container, or using like a container provided by GitHub themselves to?
No, so we got all custom containers for all these runners.
Okay.
So we got Maven, Terraform, Helm utils, like these all type of container,
Yeah.
and all these container having a specific runners going to a specific runner group, and those runner groups are tied to the specific repository. So I'll assume that there is a repository which has only Terraform. So it basically goes to prod Terraform runner group, and it use the Terraform utils container.
Thank you.
Any other questions?
Yep.
No?
Yep.
Then, Praveen, thank you very much.
Thank you. Thank you, everyone.
And then we have our next speaker, Gokul. Gokul is a passionate technologist and technical and solution architect in AWS, and he works for silver sponsor Sivo. I'm sure he has more of an intro to give himself. And with that, I will hand it over once the magic of technology does what it should do.
If it does.
Yep, all good?
Thank you. Hi everyone, I'm Gokul. I work at Sivo. So today, just want to talk about 3 business challenges that we have faced with a specific customer and my journey with implementing workspace for them. So we've been working with this customer for the past 2 years, and one of the business challenge was the customer was planning to migrate from on-premise to cloud, and we've been doing assessment since June 2021. But unfortunately on November 21, so few of the business critical applications that was hosted on on-premise got impacted because of a ransomware cyber attack, and hence we had to move the applications from on-premise to cloud a bit faster. So we spun up few applications on the cloud, but the client wanted to have a solution with which they can securely access the applications hosted on the cloud. So we recommended to go with the workspaces, and that's how we implemented the first step of workspaces to the client. So precisely, I remember we implemented 28 workspaces for a specific group of business for this particular requirement, and after that we handed over all the management of the workspaces and Active Directory and whatnot to the client, and we just rolled off. So this is a very simple architecture. We hosted a workspace in a separate VPC and just configure the routing logic to the application VPC in which the application was hosted. And that's it. A very simple implementation, just 28 workspaces to start with. Here comes the business challenge too. After a couple of months, we got a call from the customer stating about there is a huge AWS billing. While looking at it, we noticed that they've been charged $60,000 USD for using workspaces, and then we initially didn't know why that happened. So when looked at it, we found that the customer has spun up like 400 different workspaces for all the team members across the world for different business groups. So if any of the team member wants access to a cloud application, here you go with that workspace. And all these workspaces was configured as on demand, because that's how we started. So the client engaged us, and we configured the cloud cost optimizer for AWS Workspace. And this is a free tool offered by the AWS, by the way. So we executed this optimizer on a dry run mode, which means that it doesn't make any changes to the workspaces, but it gives us a report. So the report basically gave us insights, and we categorized the workspaces in 3 different buckets. Bucket 1 is the number of workspaces that are not being used in the last month, depending on the last login stats, and the number of workspaces that are being used more than 80 hours in a month, but still on demand. And the third category is the number of workspaces that are used less than 80 hours, but still configured as on demand. So the reason for highlighting 80 hours is that particular important information is being hidden. But if you use a workspace and if it's configured on demand, if you cross 80 hours, it basically you are paying more than what you would pay if you buy it as a monthly charge. So you're paying 6 times of the cost. And yeah, that's the one important key takeaway of this talk. Like, if you are configuring a workspace, just look at the usage, and if you think you're going to use for more than 80 hours in a month, please go with monthly charge because it's way cheaper rather than using on demand because it's at least 6 times costlier than the monthly charge one. Yeah, so we run the cost optimizer tool and we categorize into 3 different buckets. We decommissioned a few workspaces which are not being used, and we migrated a lot of workspaces from on demand to monthly charge, and we let few workspaces as it is because it was only used by certain group of business time to time. And the final challenge was modernization. So we found this issue while working on the second business challenge, which is, as I was saying, any user who needs access to the cloud applications was provisioned with a workspace. So there are other applications in the end user computing family like app streams and workspace web that can be suitable for specific use cases. But since we started with workspaces, the client started provisioning workspaces for all the users who actually need access to the to the cloud applications. So this is the final solution that we ended up with. So we created multiple subnet groups, and all these subnet groups has different level of access to the on-premise and the cloud applications depending on the user need. And one subnet group is basically pointing or allocated to one business group, and we started configuring workspaces either on demand or monthly charge or workspace web or app streams depending on the user needs, very specifically depending on that particular business group. So we built this entire solution using CloudFormation stack, and we packaged that CloudFormation as a pattern within the Civo pattern library, so that in future if there is another customer who wants to implement a workspace solution or a workspace web or app stream, we can just use this and spin them up with 1 or 2 groups rather than rebuilding it from scratch. Yep, that's it. Quick. This is what customer felt about after we completing our workspace. Yeah. That's it. Questions? Yep. Sorry, was that?
If they started at 60 grand, what did they get down to out of curiosity?
Good. So we brought them from $60,000 to $20,000 with the second something else. So when we did the cost optimization, we were able to bring them from 60 to 20 grand. But after the modernization, we were able to bring them under $7,000 per month.
Wow, that's a huge jump. And we're using Windows-based
Yes,
VMs?
correct.
Oh, cool. It's just Windows and Amazon Linux still?
That is correct.
Okay.
Purely Windows, because the client had a custom application which different group of business had to access. So it was a Windows application. So all the workspaces was Windows, apart from few app streams and workspace web.
And did I see in your diagram you use using AD there as well? Is that right?
Yes, that's correct.
Oh, cool. Awesome, thank you.
So we had set of shared services like AD and FSX and site-to-site VPN, CloudWatch Logs, Transit Gateway. So these shared components will be used with all the subnet groups, whereas within a subnet group will have a certain limitation about to what cloud application or on-premise application the group can connect, and that's how we control the access of workspace or app stream or whatever is being installed inside the subnet group.
Okay, so they're connecting via VPN to get to the workspace?
If a workspace wants to connect to an application hosted on-premise, it will go via Transit Gateway to the VPN and to the on-premise application.
Okay, but the users themselves aren't using a VPN,
No.
connected to a VPN? Okay, cool. Thank you.
Any other questions? No? Then I want to thank you,
Thank
Coco, for your talk. And I'll quickly grab my laptop from all the way over there. Cool. So, as we saw earlier, my first slide is not going to be a surprise. That is our marketplace segment, where we can all hold up our hands if we're hiring. I'll start because I represent the gold sponsor. Sorry, you're next. CMD, or rather our cyber division, Cyber at Mental, is looking for security experts. Fun fact, earlier today it was mentioned that Security Lake went GA. We are one of the few launch partners for that. So if you want to work, if you're if you're in security and looking to play with the latest and greatest toys, talk to us. There's a bunch of us around today. And then I think Gokul.
Hi everyone, Gokul again, part of CIVO, Advanced Consulting Partner AWS. So if you guys are looking for any senior DevOps role or data or cloud engineer, please talk to me. Happy to put you in touch with the people and culture team. Thank you.
Was there anybody else who was hiring? Just hold a hand up so I can see where you are. Quite a lot.
Cool. Well, in that case, I want to once again thank our sponsors. You've heard the names come up a bit today, but CMD, Versant, and CIVO, as well as, of course, NAB for providing this wonderful venue. And we've got a little bit of time, so feel free to hang around and talk. I believe somebody had a lot of questions for Payne. He's sitting right there, so go for it. And otherwise, I hope to see you all again next month when it is on the 28th of June, as always, the last Wednesday. Food and drinks?
Please take the food home with you.
Yeah. If there's any food left,
Yes,
yes.
there is food left. There's a little bit of food left, but it will just go in the bin if you don't want to take it home. Still good for lunches tomorrow. That sort of stuff. So please help yourself. And I can see a bunch of cans on the floor as well. If you can bring those and throw them in the bin when you're done, that'll be great.
Cool. So, thank you all for coming, and see you next time.